This week's multiple choice Monday is about mass spectrometry. And one of the things we need to know straight away to answer this question is we need to be sure what we understand by a molecular ion peak. So molecular ion peak gives us the mass of the whole molecule, i.e. it gives us the MR of the substance that's going in. That's really useful in a lot of organic mass spectrometry, and normally there's only one MR because most organic molecules made up of carbon, hydrogen, maybe some oxygen or nitrogen, and those elements do not have commonly occurring isotopes. So there's really only one option. Carbon is going to weigh 12, hydrogen is going to weigh 1. There may be a few molecules that just have these other isotopes present, but they're really, really small in number. So I'm not really going to see them on a mass spec. However, bromine and chlorine do come up in mass spec questions as having commonly occurring isotopes. So in bromine, the percentage is actually almost 50-50 of the 79 bromine and the 81 bromine. So we can work out how many possible combinations there are for the mass of the whole molecule. So we have two bromines and it's ethane, so the formula would be C2H4Br2. One bromine on each carbon, and that leaves two hydrogens for each carbon left over. Now the carbon and the hydrogen, we're being told, are only present in 1H and 12C, so they're not going to impact the number of molecular ion peaks. They're always going to have the same mass. So what we need to realise is that there are two bromine atoms, and that each atom has a possibility of either being 79 or 81. So that means we either have two atoms of 79, we have a 79 and an 81, or we have an 81 and an 81. This means that there are three possible molecular ion peaks for this molecule. The more bromine atoms I have, the more possibilities there are for different masses because of the different numbers of combinations that you could possibly have. If you just had one bromine in the whole molecule, then there could only be two possible molecular ion peaks, and that's actually quite a common thing to see in a mass spec question. You get a pair of molecular ion peaks that are a mass of 2 apart from each other. If you want to know a little bit more and you haven't already joined, then sign up to my free chemistry revision club, Cation Club. You can just go to my website and sign up there, or you can just send me a message for that. Practice exam style questions and videos on my website as well, and now I'm putting more stuff on my YouTube channel, so if you subscribe you'll get notifications for new chemistry videos every week.